On average, an Indian consumer spends over 77,000 rupees every year. A significant portion of that spending takes the physical form of packaging, electronics, and household goods, which eventually reach the end of their utility. The most visible face of this waste is the local scrap collector, traditionally known as the kabadiwala. This street-level procurement from households and small businesses represents the entry point of a sprawling industrial network. This network operates as a sophisticated economic engine, processing approximately 18,000 crore rupees every single month. It provides a livelihood for over 4 million people, ranging from foundational collectors to metallurgical refiners. Even at the foundational tier, the economics are robust. A mobile collector visiting just 8 to 10 households a day can generate a monthly income ranging from 36,000 to 45,000 rupees. This income relies on the price spread. When a collector buys 15 to 20 kilograms of plastic scraps from a household, they pay roughly 150 rupees. They then deliver that material to a regional yard, receiving a bulk premium for the aggregated load. If the foundation of the system supports millions of collectors, the higher tiers of the supply chain facilitate massive industrial transactions. Capital requirements increase as materials move to regional aggregators. Operating a scrapyard at this scale typically requires an initial investment between 1 and 10 lakh rupees, depending on the material focus. Digital platforms are currently formalizing this middle tier. Startups utilizing digital weighing and transparent real-time commodity pricing ensure that both households and small collectors receive fair market value for their materials. At these yards, primary processing begins. Chaotic piles of mixed waste are compacted by industrial baling presses or processed through shearing machines to reduce steel components to manageable sizes. This aggregation stage transforms fragmented household junk into dense, transportable batches of raw industrial commodity. For high-volume materials like iron and steel, the transformation is mechanical. Facilities take large post-consumer items, such as end-of-life vehicles, and feed them into massive shredders that break machinery down into fist-sized pieces. Powerful industrial magnets sort through the resulting debris, separating valuable ferrous metals from impurities like rubber, glass, and non-ferrous contaminants. This processed scrap is melted in electric arc furnaces. This method is highly energy efficient, producing structural steel with a significantly lower carbon footprint than traditional blast furnace production. While steel relies on volume, e-waste focuses on the concentration of precious metals. Extracting gold, silver, and copper from just 1,000 kilograms of printed circuit boards can yield up to 8 lakh rupees in a single week. In Jamnagar, the global hub for brass, manufacturers process scrap into precision components. The metal is melted, cast into billets, and extruded into rods used for high-end CNC machining. Copper scrap serves a similar critical role. Refined from high-purity electrical wires and motor windings, recycled copper is essential for the production of power cables and electric vehicle motors. This metallurgical tier generates the specific high-purity materials required to build modern power grids and digital infrastructure. Plastic recycling has also transitioned toward advanced upcycling. Modern facilities now produce recycled polymers that meet the performance and safety standards of virgin materials. Millions of PET beverage bottles are processed daily into high-performance polyester fibers. These recycled materials are used by the textile industry to manufacture apparel and upholstery for global brands. For materials that cannot be mechanically processed, such as multi-layer pouches and flexible packaging, the industry utilizes chemical recycling. This process breaks plastics down into their fundamental hydrocarbon molecules. The result is a liquefied oil that serves as a feedstock for new manufacturing. This chemical innovation allows unrecyclable waste to be transformed back into food-grade, circular plastics that are identical to virgin materials. Every ton of steel produced from scrap reduces the need for virgin iron ore extraction. By circulating existing materials, the industry provides a significant buffer against the environmental costs of traditional mining and resource consumption. Government policies like extended producer responsibility mandate brands to use a specific percentage of recycled content. This creates a permanent, regulatory-driven demand for high-quality scrap. The National Critical Mineral Mission aims to develop domestic capacity to recover minerals like lithium and cobalt from industrial scrap, reducing reliance on global imports. The collectors sorting waste in local neighborhoods serve as the primary link in this supply chain. They provide the foundational feedstock that allows sophisticated metallurgical and chemical factories to operate. As the value of recovered materials rises, the scrap sector functions as a specialized wing of industrial manufacturing. From the sorting yard to the foundry, these merchants are the architects of India's physical infrastructure.